Welcome to another episode of the .NET Show. On this show, I thought we'd have a little bit of fun and actually dive down into the deep technical capabilities of the .NET framework. Whether you're writing a C# application, a VB.NET application, or a COBOL.NET application, if it's running on the .NET framework, it's running on the CLR, also known as the Common Language Runtime. So in today's episode, we're going to take a look at the CLR and understand a little bit more about what it is and what capabilities it's providing to your applications that are written on top of it. But before we get to that, let's check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. On November 8th, Microsoft released DirectX 8.1 to manufacturing, a recognized standard for multimedia development. DirectX 8.1 provides software developers access to specialized hardware features, eliminating the writing of hardware-specific code. With DirectX, programs take full advantage of the PC, giving users the best multimedia experience possible. DirectX 8.1 offers updated graphics, faster frame rates, and improved support for massively multiplayer games. On November 27th, Microsoft announced the .NET Best Student Awards 2001, an XML Web Services contest challenging North American college and university students to develop new XML services applications. The contest will recognize student developers who innovate with industry-standard protocols such as XML, SOAP, WSDL, and UDDI to deliver the best applications and solutions with Microsoft.NET. The contest, targeted to students in the United States and Canada, will award over $60,000 in cash, scholarship contributions, and prizes to students whose web services are selected. Microsoft will launch Visual Studio.NET during VS Live 2002, February 11th through the 16th in San Francisco, California. The conference will include a keynote by Bill Gates, as well as over 180 hours of all-new sessions on SQL Server 2000, Black Belt C# and Visual C++.NET, ASP.NET, and Visual Basic.NET. TechEd 2002 will take place April 9th through the 13th in New Orleans, Louisiana. The conference will include more than 200 technical breakout sessions, panel discussions, and hands-on labs for an in-depth look at building, deploying, and managing XML web services. Those who register by February 8th can save $400 off the standard conference registration fee. Be sure to check out the show transcript for links to more information on these news items. And that's been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Now, like I mentioned, today we're going to talk about the CLR, also known as the Common Language Runtime. Now, the CLR forms the foundation for developing applications for the .NET framework. And to help us understand more about what the CLR is and how it solves some of these problems, I have Jim Miller and Jim Hogg.
Hi. Hi.
So, Jim, what exactly do you do at Microsoft?
Well, I'm a lead program manager on the Common Language Runtime. I'm in charge of what's called the kernel team, and Jim actually works for me. And our team as a whole is in charge of sort of all the low-level goo that's inside the system, the garbage collection, the intermediate language, the just-in-time compilers, the not-so-just-in-time compilers, the intermediate language design, the metadata design, the file formats, and also the standardization efforts that we've been doing. So it's a fair bit of stuff down the low-level guts there.
So what exactly is the CLR? If I want to talk to it as an object, what would you define it as?
Well, it is hard to define as a single thing. It is a combination of things. It is a file format that's used for transferring files between systems that are using the .NET framework, essentially. It is the programming GUI inside of there that lets your program run. It is the thing that takes the way your program has been compiled into this intermediate language and actually turns that into machine code and actually executes it, plus all the support services that you need while it's running. So memory management services, exception handling services, compilation services, reflection services. It encompasses all of those pieces. But just up to sort of the very lowest level to bring you up to essentially the level you would have been at, let's say, if you were doing programming in C with just the minimal runtime, no libraries above it. The libraries above it are part of what we call the framework, and that's sort of the next level of the system up.
So the CLR is actually the running functionality, and the framework then is kind of the added infrastructure functionality.
Yes, that's a good way to think about it, yes.
Now, back in my early programming days, I had an Apple II at home, and I remember the old P-code compiler that I used for writing Pascal programs with. And there actually was some that came out with a Modula 2 compiler that ran also on the P-code. And so that was kind of a multi-language thing sitting on top of it.
That's right.
Is the CLR the same thing as that?
Boy, it's, you know, like great-great-grandson of exactly that same idea. In fact, I did a P-code interpreter for a machine we designed back at Bolt, Beranek, and Newman, the same idea. That P-code design, that particular design of instruction set was very good for one particular kind of programming language, the Pascal-like languages. It had no support for object-oriented things. It had no support for functional languages. So the real difference here is the common language runtime was basically, if you had to redo that same thing, that was done in the 70s, early 80s. You're redoing it 20 years later. You're redoing it with the goal of not supporting just one language or just two languages, but really about 15 to 20 languages that covers a wide range of the kinds of programming languages people really use. That's the difference. It's sort of the same idea, but brought to a much wider set of languages and with a much richer support system as well.
I see. So, like originally, I'd always thought that the P-code compiler for the Apple was kind of just this virtual machine sort of thing. It was just taking machine code, but it actually was requiring a reflection of the languages that was being used against it as well.
Yes. So the P machine, the UCSD, University of California, San Diego designed it. So it's called the UCSD P machine. Had instructions that were things like, Pascal has sets as a built-in data type. So there was an instruction that was element of set, but there wasn't an instruction for virtual method dispatch. Pascal doesn't have virtual methods. Why would you put it in the virtual machine? And so mostly, that's how most virtual machines have been designed from the programming language community. I have my language. I want my virtual machine for that language. That's how the Pascal virtual machine is that way. There's a Lisp virtual machine, a couple Lisp virtual machines. There's a language I used to use called Scheme. We had a virtual machine. There's a language called Prolog that has a Warren abstract machine. Java has the Java virtual machine. They're all designed exactly the same way. My programming language, what I need to do to support just my language. The difference here is we said we have to support, and it really was about 15 languages. It included C++, it included Pascal, it included Java, it included Visual Basic, JScript, COBOL, Fortran, Scheme, my old favorite language, ML, we can keep going on and on, about 15 of them. And we said, this virtual machine has to do all 15 of those, and it has to do them with varying degrees of efficiency. So for some languages, C++ in particular, it really has to rival almost as good as you get with the native compilers today. With other languages, we were a little more relaxed. So with Scheme, for example, we said, look, the Scheme community has never been really interested in performance, so we need to be close to what they're getting, but we don't need to be, exactly on a par with it. So that was sort of the engineering take on the problem.
So then if we were to compare from a virtual machine standpoint, people always seem to talk about the Java virtual machine. So with the Java virtual machine, even though it's a more modern virtual machine, is more similar to the old P-code compiler because it's specifically tied to the Java language.
Yes, I think that's fair. It's a good evolutionary step also, of course, because it adds virtual method dispatch and it adds interfaces and things that were in Java, not in Pascal. But it doesn't support things that were in Pascal. Pascal had pointers, and the Java virtual machine doesn't have pointers. Our virtual machine, of course, has both. So that's sort of the difference. And it's a difference in philosophy. The other important thing to know about our virtual machine that is really different from all the other ones we've talked about is ours was designed from the beginning for compilation. So most things, including the P machine, your Pascal language compiled down to the P code, and then you interpreted the P code. Well, there was a technology that was invented about 10, 15 years ago called just-in-time compilation, where instead of doing that, you then compile the methods and down to native code and execute that native code. It goes much faster. That was added on to the Java virtual machine. The Java virtual machine was originally released as an interpreter. And then later on, Microsoft released the first JIT compiler, and then it became popular, and now most machines are based on it. But the design of it was designed for the interpreter. And it's a subtle but important engineering difference. So when we designed our virtual machine, we knew that the primary thing we'd be doing would be compiling the native code. So we designed the virtual machine to make that step possible and to get very high efficiency. So we made changes to the language design of the virtual machine to make it assume that there's a compiler there. And some of them help us get more compact code, some of them help us get faster native code. So there's a variety of interesting things that happen there.
So then we've got the CLR that supports these 15, you call them languages, as well as supporting compilation at a time, or compilation just-in-time compiling, so you can get high performance on it. Do you think that by addressing these 15 initial languages, that created a robust enough CLR that should be able to handle any language?
Well, I'm a researcher, right, from the old days, from MIT and Brandeis, and so nothing ever covers everything. Let's just face it. There are way out languages, and not some way out languages. Any language that was designed to explicitly expose the kind of native machine that exists on some native machines. For example, Forth and Pop11. These are languages that let you see exactly how your stack is laid out. We're not going to accommodate those very well.
I was hoping Forth would get out there.
I'm sorry, I actually kind of like Forth, but I don't think we're going to really be able to support that well. Even my favorite language, Scheme, has one construct in it that we don't support particularly well. It's called a continuation, and it basically lets you save your stack for later use. Those things can be done, but they're slow. And that sort of stuff, which is sort of right now, it's at the margins of the language community, not well supported. I think if we discovered in the future that those ideas were important, we know how to add them in, but they're not there in the current machine. But for really a tremendous number of languages, I don't know if you've ever seen, they call it the Language Bible. It's by Jean Sammet. Have you ever come across it? No, I've never seen it. I don't know whether Jean is still alive. I think she is. She's for many, many years at IBM collected a book that is just a page per programming language with just what its name is, where it was developed, when it was developed, and what the basic idea behind the language is. Now, when I looked at that in the 70s, it had well over 800 programming languages. So speaking for whether I could do all 800 of those, that's a hard call. Speaking about the ones that are used in teaching curriculums and in the advanced research community and in the production code, I think we cover the vast majority of them pretty well.
Yeah, I think it's fair to say as well that we cover the different paradigms of programming languages amongst the 15 or 20 that we currently have. So that includes anything from procedural languages like C and so on, all the way through object-oriented and logic. So we already cover a fair scan of the various paradigms.
So starting off with the CLR, when you first started designing it, what were some of the initial objectives you had?
Well, one of them was exactly what we just said. Probably the most important one to me personally was the multi-language design. Second one, close behind that and close in my heart and to the team's heart, was security. We really wanted to build a system where you could write your program, download it from the net, and run it and know that it was safe. So those ideas have been around for quite a while. Java, of course, made a big deal of it. They predate Java. There's been a lot of work since then, but that was another really important piece. I'd say the third important piece was this whole notion of XML web services. We really wanted to make sure we were the best way of building cross-platform, cross-architecture, really scalable services, scalable down to very small devices, cell phones, and scalable way up to server farms. And so the design of the virtual machine really had to take account of that tremendous bandwidth in the design. I mean, you really need to have some flexibility there. Those are the three big ones, and then close behind was a fourth, which is really allied with that third one, which is simplified deployment. So side by side, we want you to be able to install a component and then a later version of that component and have both on the machine at the same time, so that programs that need the old version can run at the same time as programs that need the new version we get out of this whole DLL hell. We also wanted the dominant way you deploy things is you just copy the files over there. You don't have to install them. You don't have to put them in the registry. We wanted all of that stuff. You can still do it if you have to, but that's not the major way you deploy. So we really wanted to solve that set of 4 problems: multi-language, secure, scalable web services, and deployment.
Well, let's go back and kind of touch upon each one to kind of see exactly how you implement them. Like we've already touched upon the multi-language quite a bit. What about the security? What actually did we do in the system for the security model?
So there's a very interesting area of security study that cropped up about 10 years ago, which is called trust management and code access security. Operating systems are very good at a traditional security model, which is one where there are things in the system and there are people, some principals and subjects, but people in the system, and you grant people the right to do certain things to the objects in the system. So that's access control lists, that's that whole stuff we know from the operating system world. But I started in the 70s writing sophisticated database applications, and what you wanted there was it wasn't the fact that you had access to the database files. That's what the operating system would let me do. I didn't want you to have access to the database files. I wanted my database program to have access to the database files. And it didn't matter who was using my database program. It was my program that had the right to do certain things. And that's the thing the operating systems don't do. And that was exactly what we set out to do. So the thing we're adding to the system, so we have everything that the operating system supplies because we just use the operating system to do it. That's the easy part. The hard part is how do you add this new idea in? So there's this program that comes down from the internet, and that program is not given permission to send mail on my behalf. That's how you prevent viruses. I don't have any way of doing that from just the operating system today. But that's what you get with this managed code systems, because I can say this lump of code came from the internet, and things from the internet do not have the right to send electronic mail, and then I can enforce that. And so it's not the user, it's the actual program that has the rights. And so that's the thing we're bringing to the table. And then a sophisticated setup for managing those rights. So as a developer, you can define a new privilege that things can have, a new permission that can be granted. As an administrator, you get to say what are the rules for granting which programs which rights. And that's an administrative problem, so we have tools for handling all of that. So that's what we brought to the table there, was this code access security system and the policy management system that goes with it.
So that sounds like a pretty complex systems in the workings as part of the CLR.
It's a large piece of the CLR. It is complicated to implement correctly. Once you understand it, it's pretty easy to work with it. But we have we are doing the education to teach people how it works. If you think back when operating systems started having access control lists in the 70s, we had to teach administrators how to use them correctly. We're going through the same process now. We're just at the beginning of it. So there's a learning curve there to learn how to use this new capability. But I don't think the work itself is inherently complicated. You just have to understand what it is you're trying to accomplish, what the tools are, and then it becomes clear how you do the work from there.
I think maybe one difference worth pointing out is that security was designed into the CLR right from the outset, not something that was grafted on afterwards. I mean, for example, Jim mentioned access control lists, ACLs in operating systems, and they came along afterwards, after the basic security was there, and caused a fair deal of confusion in terms of understanding the interaction with that level of security in conjunction with the underlying native security, whereas with the CLR, all of this was designed from the outset. It was right there and at the start of the project.
Now, one thing, anytime we talk about security and setting access rights, whether it's for the programmer or for the users and stuff like that, it sounds fine if you're talking about administrators and so forth like that, but I notice a bulk of the time when I'm seeing a virus-infected person coming at me with email or junk like that, it's usually not the administrators, it's usually moms, pops, brothers, sisters, and stuff like that. While it's probably not really the CLR's duty to provide a user interface that's easy to use by the common user out there, are those things that were thought about?
Oh, absolutely. There, the security problem is much more than just a technical problem, and that's really what you're saying. It's at least as much user interface and human design, and we've, you know, our team is sort of at the bottom of the stack, so we,
No pun intended.
that's right. We're really not as concerned about the user interface design as some of the teams on the framework team. We do have a group that worries about administration, and our team has been very worried about the default policies. That's the thing that affects mom and pop, because frankly, on my home machine, I install it. I don't ever adjust the permissions on a file. I don't even think about it. I finally found out where that tool is in XP if I wanted to do it, but I don't normally do that sort of thing, and I think I'm a little more sophisticated than the average home user. So you have to rely on, when you install it, what's the default. And so there, we're fairly serious about it. When you install from the internet, you really get reduced privileges when you come on the machine. That's so far, I hate to say it, but I think that's state of the art for helping out mom and pop.
Now, this model of when the programs are coming down from the internet on your machine and running, that sounds an awful lot like the sandbox model. Is it exactly the same sort of thing? Are we doing something different than what people normally talk about the sandbox model?
The biggest difference is it is a form of sandbox, but mostly when people talk about a sandbox, it means someone else has decided what you can and can't do, end of story. What we've done is we've designed a system where the programmer and the administrator can decide what that sandbox is, rather than Microsoft says this is the sandbox. So that's a big change. That's the difference between having a language and having a platform. So we see this as a platform, and the big thing you do to make a platform work is you let other people make those kinds of decisions. So we built our system from the beginning so that the people who build on top of it can choose what the sandbox is. Now we give an initial sandbox because the software that Microsoft ships, some parts are marked as usable from outside by default and some are not marked that way. But those are changeable by administrators, and any new code, whoever writes the new code gets to make those decisions. So it's like a sandbox, but a better way to say it is it's a system for building sandboxes. That's what platforms always are. They're not the application, they're the system for building the application. So we've taken that extra step, and I think that's what Microsoft's real value, if you look at the ecosystem of all the software companies, that's one of our unique abilities, is to step back and build the platform rather than the application. We do applications and tools too, of course, but building underlying platforms is a real specialty, and I think we've done that in a really nice way.
Okay. Any other remarks on security before we move on to something else, or that seems to
I think
cover it?
the other thing to say about security, well, two really. One is, because it's not the focus of our team, we always belittle it, but it's at least as important, is the integration with all the stuff that's already in the operating system. So that happens in the class libraries and the stuff layered on top of us. So don't forget that in addition to the security we provide, the operating system provides it. And we do have mechanisms for providing both and make sure that you can flow one through the other, and that you can do impersonations, and you can check who's impersonating and who the real person is, and all of those facilities are all available. So you didn't lose any of that. And the second is something we'll probably come back to a little bit later, which is one of the core issues I talked about was scalability. And one of the ways we get scalability is something called an application domain. So if you take a normal process, it takes a while to create and kill a process. And when you want really high performance, you want that one process to be used for many, many things. So this is what transaction processing systems typically do. We wanted to get the same kind of idea with an easier programming model. And so we created this thing called an application domain. And the idea is you can have as many application domains as you like inside of a single operating system process. And a combination of our security system and the design of the instruction set, the virtual instruction set that we designed for .NET, guarantees that programs running in this application domain can't read or write the memory that's being used by this application domain. So that means they can run in the same process together without hurting each other's memory. And so that lets you scale to tremendously where you couldn't before, because we can have hundreds of application domains in a single process, hundreds of processes on a single machine, and hundreds of machines in a single server. That's where part of this scalability comes from. So there's been a lot of work to make that piece, which isn't exactly security, but it's deeply related.
Because it's sharing some of the same constructions that you had between the security and separating things out quite a bit.
Yep.
Yeah, I think a question I'm often asked about app domains when we explain what they are is that, well, processes, they're separated from each other because, well, or with assistance from the hardware on the chip, on the Pentium, for example. So do you require special hardware to actually deploy these app domains? And the answer is no. In fact, the isolation between app domains within a process is not provided by hardware assist, but instead imposed and policed, as it were, by the software that constitutes the machine, the CLR itself. So it doesn't require special hardware. App domains just come, as it were, for free as a feature within the CLR itself.
It's part of the built-in infrastructure of the CLR.
Very much so, yes.
Now, you also mentioned in your list of things to do that making sure that the CLR could support writing great XML web services. How does the CLR, is it designed for doing that?
That's subtle. Things like this ability to have the application domain for the scalability is one of the things we did to do that. We have a remoting system and we have a metadata system, so we can describe all the data types and all the programs that are built. And in fact, when you compile, and in fact I think Jim will show this later on, when you compile, you generate not only code, but a description of the code that says all the data types it defines and what the methods are and what the fields are and so on and so forth. That stuff is exactly what you need to describe a service on the web with XML web services. So all of our compilers, because they're compiling to our intermediate language, are automatically producing the same information you need, and then of course we provide an automated tool that takes it from the binary form that's needed for efficiency that we use and converts it out to the part that you could send over to somebody else to describe it with WSDL. So the tools that take our metadata, turn it into the XML form on the web are part of the system, and the reverse thing. We can take the description in XML and turn it into our metadata. And so that's a deep connection between web services and the runtime at the very, very lowest levels. So that one's one that's emerged as we've done the work. So we have been designing the metadata, we've been working with the people designing WSDL, and we said, you know, these two, mighty similar, what do we need to mesh them together? And while the work of meshing them together isn't complete, we're working on a next version of the WSDL standard that will make them completely match. So
So you
right
have
now,
one thing rather than one that can create the other.
well, it'll still be two representations because the XML one, it's larger, it's slower to parse, all of those sorts of things. It isn't what you want to use on the machine. It's what you want to use to communicate between machines. So you're still going to need a conversion. The problem we had was that we could represent everything you could say in the XML, but we could say things that you couldn't say in XML. So we could take any description of any web service anywhere on the planet and generate programs. That was never a problem. The problem was if you wrote them without thinking about that, what you wanted to do, sometimes you couldn't make a web service out of it. And that's what we want to fix. So, you know, that's sort of the next piece of the work. And that's more on the standard side than anywhere else. All the mechanisms, everything is there. Just we need to get the standards and the products in sync. And then, you know, that's always a trick at Microsoft, right? And elsewhere too.
So when you were talking about how you know great the metadata describes the structures of the CLR of the application you're writing, so like that reminded me of a question that I get asked quite a bit. I'd like to hear your take on it. And that is, since the CLR is an intermediate language that segments itself out pretty well, and you got this thing that describes the application very well, that means you can write this decompiler thing that can take your application that you wrote and turn it back into source code again, whether it's C# or VB and stuff like that. And that was one of the big problems with the web, is that you write an HTML page and you ship that out as a web page, and everyone can read your HTML code and know exactly how you did that cool effect.
Yep. So it's certainly true. what you just said is true. You can do that to IL. It turns out that if you just go out on the web and do a little search with Google and your favorite search engine, you will find half a dozen things that will do that with x86 code too. So it isn't noticeably different. What's different is that the metadata often contains a lot more information than you would have put in that x86. It's not because it's needed, it's because it makes certain things easier. Now, you can remove some of that. Some of our tools do that. And we have we're suggesting what's called an obfuscator. That's something that removes a lot of that information which isn't needed. So you don't need information about the private methods and the private fields. That can be removed. More to the point, you can take all of the names of these things and mix them up in a way that you can't untangle them again. And so you can't print them out. Now, if you've ever tried this, just take an old assembly language program in the good old days when you're only allowed 6 characters for your variable names. You can't figure out what those things are doing. I don't care if you turn it back into C code. There was a very famous paper by an old friend of mine, Guy Steele, who's deeply involved with Java at Sun. He wrote this when he was in the Lisp community, where he just took a trivial program and changed the variable names to very long strings that only differed by a couple digits at the end. And I think the program is only 15 lines long. And he challenged anybody to explain what that program did. You can't do it. And you have to try it. People don't believe you till they see it, but just do it. Take a program, obfuscate it, turn it back into C#, figure out what it does. It's almost always hard. Plus, the other thing that, I didn't say this, but it's core to the design, I mean, absolutely core to our design, is that it is very easy and very fast to get back and forth from this managed code in IL to native code written for the x86 or the i64. As a result, for the parts that you really consider ultra important and you think that putting them in x86 is going to help you, which I'm not going to argue anybody on that point. I don't know what extra benefit you get, but if you think you do, then you can easily do that. Put the core pieces there and just interoperate with it. That gives you a good answer. Now, the real answer, which I'm dodging, is the digital rights management solution. Whatever we do for digital rights management with a secure bootable operating system, that's the real answer to this question. And nothing you do is going to get you where you want to be until we've got that digital rights solution. So while our team isn't working on that, we have another team at Microsoft that does that. Our security architect just moved over to work on that team. And I believe that that's where, as an industry, that's where the solution to this problem lies. It doesn't lie in our technology or staying with the x86. If you really care about that level of protection, you need some digital rights management solution.
Which probably sounds like it's another show sometime in the future. Then.
I hope so. I hope so.
Now, there's one last point then that you're describing that you wanted to cover in the original 4, and we've actually been touching upon it this whole time, and that was the deployment capabilities.
Yes. So there are 2 things that we've done there. Managed code, the stuff that you get when you compile to the intermediate language and so forth, does not use the registry. It simply doesn't use that mechanism at all. And that's been one of the key problems for deploying applications. You deploy one thing, it needs to write its settings into the registry. You deploy the next version of it, it's got to go in the same place in the registry. They collide. You can't have both of them on the machine. Well, we don't rely on that mechanism. We have a completely different mechanism where you deploy your application into a directory, and we will preferentially look there for the components that you reference. If we don't find it there, we'll look in a shared location, but that shared location, everything has a version number on it. So when you compile, we capture the version number of the thing that you wanted, of the shared component you wanted. And at runtime, we can go and look for that shared version or a compatible shared version. And we can run that in the same process with you, and we can have another program in that same process in a different application domain that needs a different version of it. All of that works just right. So side by side of applications and components really works in this platform. And it gives you 2 things. It gives you the ability to not worry when a new version of a component comes out. You don't have to ask the question, do I install it and maybe break existing apps? It won't do that. You can just install it. New apps that need the new thing will use it. Old apps, if it's compatible, we use the new one. If it's not compatible, we use the old one. All of that's been automated for you. There are administrative controls too, so if the automatic things don't work, the administrator can adjust it back to working, but primarily it's automatic. So that's the biggest pair of things really, is fix the deployment problem. Mostly you deploy by just copying it where you want to be. If you want it shareable by many things, you actually do an installation step, but that
Because you've got to
installation,
split up between the shared components and the non-shared
yes,
components.
the shared components need to go in a shared place, so you do have to install them as shared, but because the version number was built in, they don't get confused with previous versions and future versions, and all of that stuff carries through. So a lot of thinking has gone into that. It's supported very well at the lowest levels of the system. As it bubbles sort of back up, it's not as supported in some scenarios and other scenarios, but we're working on that over time. But right now the basic mechanism is there, and it's quite stable, and it's looking good. But until we roll it out and see what the market does, we won't really know. That's one of the areas I'm most interested in. I think we got it right, but
I'm just thinking, Jim, that you've described there that on any given machine you can have multiple versions of an application, multiple versions of libraries and so on. And maybe folks are wondering, well, is there any special exclusion there? What about the CLR, the Common Language Runtime itself? Maybe there's a constraint, you can only have one version on your machine of that. But in fact, we've addressed that as well. It is possible that as new versions of the CLR come out, you may have a server that has multiple versions of the CLR itself. So within any one given process, you may run application A with version 1 on version 1 of the CLR. In another process, you may have a different application running a different version of that on a different version of the CLR. So we've looked at versioning and easy deployment and the avoidance of DLL hell that Jim mentioned earlier, both for the CLR itself as well as the applications that layer on top of it.
Well, it's kind of exciting, almost like now that we have larger hard drives, we can do stuff like that. Back in the old days when DLLs first came about, it's because hard drives are so small, we had to kind of compact the things as much as possible.
Yep.
Is there any concern about maybe by having side by side, we suddenly start needing even bigger and bigger hard drives and start running out of room out of these 40, 50 gigabyte hard drives?
I don't know, you can buy 40 gigabyte drives for a couple of $100 now, and it's becoming cheaper and cheaper all the time.
This is an awful thing to say. It's not worth optimizing for the disk space anymore. Working set, yes, but the price of those disk drives is dropping rapidly, and I can't imagine that that's an issue. Now, obviously, we have tools for cleaning it up and removing them when they're not needed and so forth, because who wants to waste the disk space? But it's hard to think that that's the dominant factor that it was 5 years ago even.
Even if you think back a few years ago, because of constraints on disk space, there were a whole range of software technologies like disk compression and so on, which seem to have gone away because now disk space is cheap, so why pay the extra cost of compressing and decompressing when you access data in a file? No need for it, just buy another hard disk. So.
I should add one other thing, which I sort of sidestepped because it's not our core team, but the design of the engine and all of the intermediate language and so forth was seen, as I said, for scalability. Our team is charged essentially with things of laptop-sized computing up to the big end. But we have a sister team which is called the .NET Compact Framework, and their goal is sort of notebook computers down to cell phones. Now on their side, that becomes a serious issue, as does memory space, as does, they're back where, glad somebody's doing it and glad it ain't me, right? That's where I started the field in the 70s, not enough memory, not enough speed, not enough disk space. Other than that, it's a jolly wonderful place to be. So they worry about this. They can take the benefit of this side-by-side story. I don't actually know what they're choosing to do. My bet is that you won't find many devices in which you will have two versions of the runtime side by side on your cell phone in the near future, because those are the critical issues there.
So I'll probably have to have Ash on the show one of these days and talk with him and ask him that
That's
question.
exactly right. Yep.
You may be able to tell the answer if he comes along with 2 phones.
Side by side.
Side by side. Yes,
Okay, well, thanks. I hope we answered some of the questions my audience has about, the architecture and components and issues about the CLR, and thanks for joining us. So hopefully that touched upon some of the higher level things of why the CLR was created and what it was trying to do. After this brief break, Jim Hogg will come back and talk to us about some actual code of the CLR.
I've always been a proponent of the zero-based array.
I'm a zero guy all the way.
Zero. Zero.
Everything starts at 1. 0 means nothing.
Everything should start at 0.
Zero-based arrays, one-based arrays. Some people just screamed at us, and some people were very happy, but we had to make a choice.
I don't have
I have no opinion.
I think there's a world where zeros and ones can live together.
They're nice people, I'm sure.
For accessing and working with data, I think of the first column, the second column, the third column. I don't think of the 0th column, the 1th column, and the 2nd column.
We're a big company. We can see the differences.
Some of my best friends believe in one-based arrays.
Yeah, I'm a zero.
I've been converted to a zero-based array.
Definitely zero.
Zero.
I have to admit, I've been broken. Zero is the way to go.
When I was doing VB development, it had to be zero-based.
I have a dream where all arrays are created equal.
I think Microsoft people tend to argue for the sake of argument. I say pick one and move on with it.
So we've already covered the architecture of the CLR and what it's intending to do. Now it's about time we dive into some code and actually show you what the CLR can do. So here to join us now is Jim Hogg. He's going to show us exactly what it means to write some code and use the CLR for writing applications. Welcome back, Jim.
Thank you.
So what do you got showing here for the CLR and some real code to show our audience?
Well, what I want to do during this session is look at how we build a very simple application and then focus not so much on the application itself as what happens after you compile it and then when you start to execute it on top of the CLR. So the application that I've chosen, in fact, is probably the simplest that you can imagine. It's a small program that does no more than print hello world to the console.
Naturally.
It's a standard. So what I've got here is, in fact, just switching on to the laptop. I've got,
looks like a PowerPoint slide to me.
It does.
So,
but soon we'll get to the real
That means
thing.
you are the first person ever to have a PowerPoint slide on the .NET show.
Breaking new ground all the time.
Okay.
So we'll start here with a couple of examples of a Hello World program. And as we mentioned earlier, because we're targeting the CLR, you have a choice of, 15, maybe 20 different languages in which you can write your Hello World program. So here's a couple of examples. The first one in visualbasic.net. And as you can see there, it's a very short program. First line just tells us that this module is called hello. Then we dive into the main subroutine, takes no arguments, and it's got just one single statement, which is a call on the WriteLine method in the system.console class, one of the standard base class libraries, to emit that literal string, hello VB world.
So this is actually then calling out to the .NET framework.
Correct.
To issue that WriteLine call.
That's correct, and we'll see in detail later just how that actually happens. Down below there's another example program, this one written in COBOL. At least so I'm assured, because I don't know COBOL myself, but when we ship the first release of CLR, there will be, as I say, a whole host of languages available, and the COBOL one is being provided by Fujitsu, in fact. So there's a couple of example languages, but of course they're fairly high level. And you may ask, well, like in the old days when we had unmanaged code, we used to have assembler language, lower level stuff that got nearer the hardware, as it were. So do we have the equivalent in CLR? And the answer is yes, we do have an assembly language, and it's called IL for intermediate language. So if you really wanted to, could you write a program that says hello world in IL assembler? And the answer is yes. If you're sufficiently masochistic, here's how you do it. So let's just step through the lines to show how simple this is, in fact. The first one is a .assembly directive, and that just says this assembly is going to be called hello. The next one says .assembly extern, and this is a reference to another library. And it's the library that comes with the system, the main one that contains all the functionality for the base classes, in particular to write to the console, string manipulation and so on, and it's called MS-Corlib. We didn't notice a reference to MS-Corlib in the previous examples. That's because these high-level compilers do that automatically on your behalf. Then we dive straight into the main method. It's a static method that returns nothing, and it's public. And the next line says .entry point. Now, again, this is slightly different compared with conventional languages. We've called this main method main, M-A-I-N. We could have called it anything. What actually counts is we tag it with the .entry point directive. That's how the CLR knows where to go when we first launch the application. And then we come to the actual raw code itself. And there's only 3 instructions. The first one, loadster, which loads a pointer to that string, hello IL world, onto the stack of the abstract machine that we discussed earlier. Then we call a function, the writeLine function, which is provided on the system.console class. And as we said earlier too, that comes from the MS-Corlib assembly. So everything's spelt out in full, as you can see, even to the point of saying the type of parameter that routine takes, which is a reference to the class system.string. And then the last instruction, ret, a single byte that says we're done. So that's how it works in IL assembler.
Now, since, back in my own assembly language programming days, I know that you take something like this and pass this through a preprocessor that would turn it into the machine code. Mm-hmm. Could you write IL machine code too?
In fact, you can, and that in fact is what is the output of all the languages that have compilers targeting the CLR. You can do it with this, with a little program called ILASM, which stands for the IL assembler. So that's how we do it in the low level down at IL, but for the rest of this session, let's just do this simple one of the simple version of Hello World, and this is written in C#. And again, it's just what you would expect to see, a few lines of code. It's only got one class, the hello class. It's only got one method in there, main. Notice it's spelt main with a capital M. It has to be. That's just the convention that this particular language imposes. And the output is provided by a call to the writeLine method again of the system.console class. So that's done with a PowerPoint now.
Okay.
Let's go down now to a command line.
There you go, I'm more comfortable now.
So I'm sitting just now in a directory, so let's just show you the contents of what's actually in there. And as you can see, I've got these programs, hello.cobol, a C++ version, a C#, the IL one that we mentioned earlier, and the Visual Basic. So we'll choose the C# one, and let's actually build that, compile it, and produce an output file that the CLR will then execute on our behalf. And to do that, I'll stay down at command line level rather than use our Visual Studio, because it's kind of a low-level discussion that we're having. We're focusing on the internal nuts and bolts. So let's keep with command line. So we'll say CSC to invoke the compiler, ask for debug, and just say hello.cs. I got that wrong. Poor spelling.
So it looks like the CLR doesn't help your typing much, does it?
Not much, I'm afraid.
Okay.
So that compiles, and it produces, as you would expect, 2 output files. We'll just do a dir and show them. And there you see hello.exe, which is the file that we're about to execute, and another file, hello.pdb, that contains the debug symbols that will help us debug this when we come to do that later. So I guess we better just check that this program actually works. So if we type hello, then sure enough, it says hello C# world. So that's how we get the file that we're about to execute, hello.exe. And we call that in CLR terms an assembly. But what actually does that assembly contain? Because it looks like a .exe file, so is that the same as .exe files that you used to build with Visual Basic 6 and Visual C 6 and so on? And the answer is Not really. It's got the same name, but if you look inside, it consists of 3 sets of information. The first one is a header called the PE header, and that's familiar to users of languages before CLR came along. It contains essentially a table of contents that tells you where the rest of the information is in that file. And we'll look at that in a second, and we'll use the well-known tool dumpbin that comes with Windows and has done for years to look at that header. The other 2 parts of the file consist of metadata and IL language converted into binary that you asked about earlier. So let's ask, well, what is metadata? What is IL? If you think back to our source program for Hello World, or in fact any program, no matter how big, it divides into 2 parts as well. It divides into the declarations, for example, the classes, and inside the classes, the methods, the fields, the properties, and the events that you have. And all of that information we capture in metadata. So that's one half of the story. What else is in your program? Well, it's the things between the squiggly braces, right? It's the code. And the code for each method, that ends up as IL binary. So that is essentially the breakdown. Metadata, the stuff outside the squiggly braces. IL code, the stuff inside the squiggly braces. So we've got our hello.exe. It's got the 3 parts, the header that we'll use dumpbin to look at, and the other 2 parts, which are new for CLR, they did not exist before, the metadata and the IL binary. We'll use a tool called ILDASM to examine that. So let's start off with the first part. So we've got hello.exe sat there, and we're going to use the tool dumpbin, and we're going to, let me just clear the screen first and get that out of the way. So we're going to use the tool dumpbin, ask for all the information in there in the file hello.exe. And there we go.
So saw the PE header there at the front, and now we're getting down to the other data.
It. So let's, there seems to be a lot, and we're not going to go through this in huge detail. But let's go back up to the top.
I love the fact the command line scrolls back and forth like that. In the old days, until the 40 lines or whatever, it's a lot better now.
It's lovely. So if you were looking at the output from dumpbin from a conventional program, then everything is just how you expect it. You just scroll down, it's all the same stuff, and you should feel comfortable with it until you get to the number of directory entries in this PE file, because now there are 16 of them, and that's more than there used to be. And the extra one, number 14 down here that I'm trying to highlight, got it, called the com descriptor directory, is new, and that is the part that tells you from this table of contents where to reach the metadata and the IL. And the presence of that is what essentially says that this PE file is a managed file that is executed by the CLR. So we'll just continue a little bit further down.
So now, the fact that the PE header has that in there to tell this is going to be a managed code executed by the CLR, does that mean that the process within Windows, when the operating system now, when it launches an executable, the CLR has to add something to that so it's able to interpret that? Because otherwise, Windows today doesn't really know anything about the CLR, so it wouldn't know to look there, it wouldn't know to pass it on to it.
That's a very good question. In versions before Windows XP, in fact, the operating system didn't need to know about the contents of that file. We had a fancy, tricky bootstrapping technique that allowed us to get the CLR launched before the code was reached. From Windows XP forward, the operating system's aware of these new types of file and gives us a little bit of help in that bootstrap process.
I see. So even though Windows XP doesn't have initially the .NET framework built into it, or the CLR, it has enough knowledge of it that can assist you in executing these programs.
That's exactly correct. So let's just stroll down and see if we can find some more interesting stuff. And in fact, we've reached section 1 here, and we're in fact staring at the metadata. So there I'll highlight hello.pdb, that's just like a conventional PE file. It's the location of the debug symbols for this image when you come to run it. And then we come to the start of the metadata itself, and you can tell by these 4 letters, BSJB. They're always BSJB, and it's the first 4 characters at the start of the stream that constitutes the metadata.
And BSJB stands for what?
Well, actually, it's the names of the 4 guys that worked on the building of the metadata engine in the V1 product for CLR.
So I suppose if Mark Zbikowski can stick his name in the exe header, you guys can stick your names in here.
Except it's more compressed. We've got 4 people into
Okay.
4 bytes. Moving on, there's another thing there, v1.0.3512. That captures the version of the runtime that we used to build this program. And on this laptop, it's 3512, which is release candidate 3 from, when that's going to be, a couple of weeks ago, the 12th of November that was built. And then we're into the midst of the metadata after that, and we won't look at that because we've got a better tool to look at that, which we'll see in a few minutes. I'll just pause for a minute here, where we see a dump of that entry number 14 in the directories, the CLR header. And I'll pick out this item here, which is the entry point token. Remember that we're looking inside a PE file now that has no code to execute. There's no native code in there, so you can't turn it loose to the Pentium chip to start chomping on. We've got IL instead. So at some point we need to turn the IL into native code, and that is carried out, as we'll see in a little bit ahead, by the JIT, or just-in-time compiler, which is a component of the CLR. And it needs to know where to start executing code, and this is what tells us. The entry point token with that funny value, 60, and then the lower 3 bytes with a value of 1. And I think the only other thing I'll mention in this dump is here. We've got a link from this file to another one called mscoree.dll. And that, in fact, is the front door, as it were, to the CLR. That's where we go first in order to bootstrap the CLR into the process that we're about to start executing this code from. And in particular, that routine name, underbar corexe main, is where we go within that DLL. So that's it for looking with dump bin into the PE. So that's examined the header, and we've poked a little bit into the metadata that lies below. But now, again, we'll just clear the screen there and start looking into the metadata and the IL itself. And for that, as I mentioned earlier, I'll use a tool called ILDASM. It's the other half of the ILASM, the tool that took us from the IL source code down to IL binary. This one goes backwards. Okay. So we'll give
It's
that...
kind of like a decompiler, like we were talking about in the first half of the show, sort of, or not quite?
It's not quite. It starts from IL binary and produces friendly, easy-to-read text, but it's still at IL level. It's not in a higher-level language. So let's just do that. We'll do ILDASM hello.exe. And as we can see, this pops up a little window, and it shows us the contents of that PE file, the metadata and the IL, but in an easier to read format. So we have hello.exe is the name of the file. We've got a class called hello, and inside that class we have not very much, because it's a very small program that we started off with in C#. First of all, we have the fact that the hello class is public. Not much more to say about that. There's a method in there called .ctor, and in fact that is a constructor method. So anytime we create an instance of the hello class, we run a constructor for that instance, and we can look inside that by double clicking. And there, in the IL language, is what that constructor does for you. Now we didn't notice the constructor in the original C# source. C# has been kind and manufactured one for us. And what does it do? Not very much, actually. All it does is call the constructor for the parent of the hello class. And all classes within the CLR are parented by that one at the top of the tree, as it were, called system.object. You might ask, what if we peered inside system.object, inside its constructor? What does it do?
What if we peered inside a system.object? What does it do?
Nothing, actually. All it does is execute the return instruction. So in fact, we're about to call that method to do nothing, return, and in fact we do nothing ourselves in our own constructor. So this whole path looks like good to do had there been anything to do, but we'll end up doing nothing. But we'll come back to that later when we examine the actual executing program.
Because it looks like just wasting cycles.
It does, but we have an answer to that.
Okay.
So finally, we have the static method main. And when we look at what that main method does, when we look at what's inside that main method, remember it was written in C# originally, it looks very much like our program written in IL. It's only got 3 instructions. The total code size is only 11 bytes, okay, so it's very compact. And those 3 instructions are the load string instruction, the call to the write line method of system.console, and finally return. Simple as that. So we've now looked inside that file, got a feel for the different pieces of information that are in there. But probably time now to say, well, what happens when we execute it? You know, when we either run hello.exe or double click its icon within Explorer, what happens after that? And to do that, again, we'll stick with a low-level tool because we're down at nuts and bolts level. And it's called CoreDBG. It's a command line debugger. So let's just run CoreDBG up on the hello program. Okay. And I'll do the show command. So that just gives us, again, the original source of our program, written in C#, and it's getting this because we have the source program there and we have PDB symbols. On the left there, the asterisk at line 3 just indicates the instruction that we're about to execute. We're in the main routine, we're about to call the write line function. So there's a command within CoreDBG which allows us to trace what's going on as the thing executes. And I've forgotten what it's called, but I know it's mode something. So if I type mode, that tells me all the current settings that are in effect for the CoreDBG program. The one I'm interested in is app domain loads, that one up the top. So I'll enable tracing of loads and unloads of assemblies as we load them into our process by just typing mode app, well, I can shorten it to app instead of app domain loads, give it the value 1, and sure enough it tells me now that tracing of these events is enabled. And so if
Who needs dialog boxes with radio buttons and stuff like that when you got command lines, you know?
This is the new technology that's coming back, I feel. So if we just look at the program again and we run that program, with go, then what's going on? Oh, sorry, let me just replay that again. I'll load hello back in, ready to execute. Okay, and then type go to execute it. So if we look back to the run hello command there, what's happened here is that it has reported an assembly being loaded, and the assembly is that one. It's MS-Corlib, the thing that we mentioned earlier. It's the sizable DLL that holds lots and lots of the base classes that come with the system.
So in your IL assembly version of this, you had to manually enter that in, where you said in the C# version it was doing that automatically, and in fact that's what we're seeing it happen
And
here.
that's what's causing that to be paged in, yes. So we've got MS-Corlib in, and the second assembly that comes in is hello.exe itself. We then run the program, we emit hello C# world to the console, and then we tear down the assemblies that we loaded by first of all unloading in reverse order hello.exe and MS-Corlib. Finally we exit and the program's done. So going back to that mode command, you can in fact request even more tracing information than that. There's a couple of things that you can turn on. Module loads to see each file coming in, because an assembly can, although in this case each assembly we have, mscorelib and hello.exe, only has one file in it, one module. You can build assemblies with multiple modules in, so you could see each one being paged in as it happened. Or for even more detail, you could enable class loads, and there you would see every single class as it came in and then got unloaded at the end of the program. I won't do that, however. Instead, we'll just turn off the event tracking for app domain loads by setting it back to 0. And show you something else that's useful in understanding what's going on here. I'll load the hello program back in, ready to execute, and then explain that when we execute the program, what happens? I mentioned earlier when we were looking inside the program itself, there is a thing called mscoree. Well, that in fact is the front door to the CLR. There's only one version of mscoree on any machine, and it's in the System32 subdirectory of Winder. It's a very small DLL. We call it the shim DLL, in fact, and its sole job in life is to look on this machine and find out if there's one or more possible versions installed of the CLR itself, and figure out which is the correct one to launch for this application. Having made that decision, it then loads in that version of the CLR as required. That version of the CLR then looks at the entry point for the code that it's about to execute, in our case the main method for the Hello World program. That's written, remember, in IL, so it's not in a state that could be directly executed by the Pentium processor. The CLR knows that, of course, and it invokes the JIT, the just-in-time compiler, to convert that IL, method by method as required, from IL down to Pentium native language, and then hand it off to the chip to execute. So we can actually see the execution taking place, because in CorDBG we have a command called WT. In fact, there's lots and lots of commands within CorDBG. Just typing help shows you them all. Lots and lots. The one we're interested in is the one at the end there, WT. So let's just load in hello again. Type WT. And what happens now is it traces all the calls that go on to make up this Hello World program. And
That's
as
a
you
lot
can
of calls.
see, there's quite a few. Let's just page back and just see what was going on there. As you say, there's lots of calls. So starting at the top, we start in main, and we execute a couple of machine instructions. And then we jump into execute .cctor, which is the class constructor for the console class. 13 instructions into that, we jump into another method, the open standard output method for console, and so on, and so on, and so on. And this goes on for a very long time, as you can see. But eventually, with patience, we get to the part where we start to actually do what our program requires, which is emit this string hello C# world to the console, and then run down towards the end of the program. And as you can see, quite a few instructions in there, 3,383. Now there's one thing to be aware. We are executing within the environment of a debugger, and therefore we want our code to be easy to debug. So as part of that process, because we compiled it with /debug, that information has been handed on to the JIT compiler, and the JIT compiler has said, it wants to be able to debug, so I'll be friendly. I shall not do any optimizations on the code. So it will take the IL code that is given and convert that into native machine code that can be executed, but it won't do any fancy optimizations. But within CorDBG, we can tell the JIT compiler to forget that by enabling, using the mode command again, mode JIT1. And now, as you can see, the JIT will produce optimized code. So let's just load in hello again and see if it makes a difference. Type WT. Hey,
Much
that
shorter.
seems a bit
Much
faster. In fact, the number of instructions there is 374, it reports, and that's about 10 times less than what we had originally. So how can we do that so fast compared with the unoptimized code? Well, because the CLR JIT compiler does lots and lots of optimizations. It's a full optimizing back-end compiler, as it's called. One of the very significant code optimizations it does is inlining. So when it goes down compiling a given method, if it sees a call to another method, it goes and inspects that method and says, I wonder if it's a small enough method, instead of calling out, I could actually grab its code across here and embed it in the calling routine. And remember when we were talking about the instance constructor for our hello class that called up to system.object, which in turn did nothing except return? Well, the JIT compiler has examined all of that as it went and worked out, in fact, that not only can it inline all of these things, it can throw them away because there's actually nothing being done in that particular code sequence, and so end up executing the same program with the same output in 1/10 of the instructions. So it's just one thing to be aware. If, when you come to write code and analyze your performance on the CLR, be aware that if you're launching from within a debugger, the JIT is being told beneath the covers to ease back in its optimizations. And if you want to do serious, real performance studies, remember to enable the JIT to do these optimizations, because your answers will vary greatly compared with the unoptimized case. I guess that's about it. Just in summary, we've gone through, we've looked at the output of the file, we've examined the header, we've examined the metadata, the IL, and then we've looked in the second half at how that gets loaded into the process and executed first by JIT compilation and then handed off to the Pentium processor to actually execute the raw instructions.
So all this decompiling, what a Hello World application does, in your case in C#, but you could have been doing this in VB.NET or in COBOL or something like that, and probably it would have looked basically the same way on the screen.
That's absolutely correct. If you look across the range of languages, they may have different syntax when you write the Hello World program. For example, contrast a language like COBOL with something else like Haskell or Component Pascal or whatever. So it looks different at the outset. But when you do examine the IL, there are differences, but essentially it is the same IL stream. And then the hard job of converting the IL into really good, fast, compact native code is done once instead of by each compiler. It's done once by the JIT component of the CLR.
Now, how often would a developer need to come down to this level and actually be using some of these tools to examine his code?
Very rarely. Very rarely. I just do this because it's so much fun. But for routine development of Windows forms, web forms, etc., database access, developers there would make use of the Visual Studio IDE, which gives you a much higher level and much friendlier level of what's going on in the code. It's rarely that you would duck down to this level. This is just done in order to look inside under the hood, as it were, at the nuts and bolts of what's going on.
Now, the command line tools you use here, is this part of the Visual Studio.NET product, or is this part of a .NET Framework install? Or
it comes with both. It comes with the .NET Framework itself, the Core DBG, the ILASM, the ILDASM tools, and a whole host more. But also when you install Visual Studio.NET, all of that comes in first.
Okay. Well, I appreciate the time you spent with us walking this code. Are there any final words of wisdom you want to offer to developers that are going to be using the Common Language Runtime for developing applications?
I guess most of my past 2-3 years within the team has been spent at this level, and in honesty it's only been in the last 2-3 months that I've had the time and opportunity to start using the Visual Studio IDE and looking at the higher layers of software. And you know what, it's real fun to go from the low-level stuff to the higher level, to see just how easy and how smooth it is for a development experience to actually put together applications so fast compared with this low-level stuff.
Well, thanks, Jim. I appreciate you joining us.
Thank you.
So that brings us to the end of the coding section of the .NET show. We've got a few more minutes left to go in the show, so stay tuned and we'll see you next time.
Designing for new hardware and software products at Microsoft doesn't just include the UI. There's also the logo and other branding elements to consider with a new product. With me today is Horace Luke. He is a creative lead at Microsoft. Horace, welcome.
Thank you.
So why don't you tell me about which kind of groups you've worked at Microsoft and the different projects you've been involved with?
My history at Microsoft is that I started at the Xbox team. My role at the Xbox team was that I designed the hardware, influenced the software as far as creatively, and also strategically helped the company define what the brand was and design the logo for the product. Then I moved on shortly after that to actually relook at Windows as far as what the brand means to Microsoft and to the customer. And I was part of a committee that both realigned the Windows strategy and also designed a new logo that represented that new strategy for Microsoft.
So where do you get your inspiration for designs? Do you do any sort of like research or usability to determine what customers are going to respond best to?
Well, there's two parts to it. There's the science and there's the magic. The science is, yes, we do a lot of research. Let's take Xbox, for example. Before we started putting pen to paper and designing anything, we went out and talked to thousands of gamers, visited probably 50, 60 homes internationally, and sitting down and seeing how people actually do gameplay so that we actually put ourselves into their shoes, so to speak, and know exactly what we're designing for and who we're designing for. And then there's the other part, which is a little bit of magic, that they're, through culturally going to shopping malls, looking at most current stuff, getting magazines, you get a really good snapshot as to what is the most current thing.
Sure.
And it comes from the gut. So that's the magic that kind of uses the science, but not totally. It's not mathematics. You can't go 1 + 1 = 2, and here's your design. You can't do that.
It's kind of like the latest fashion hit. What's visually is going to catch people's eyes. How did you come up with the Xbox logo? For example, why did you choose that color green and kind of the Xbox font sort of logo?
Yeah. So there's really three parts to the Xbox brand, so to speak. I'll be lying if I didn't say it was luck that green happened. Actually, green was a color of the marker that I had in my pocket the day I started drawing a lot of stuff for Xbox. And, I was actually in the middle of an office move, so I didn't have any more markers, and all I had was a green marker. So I started coloring everything in green, and next thing you know, the game developers fell in love with it. Partners fell in love with it. The internal folks looked at it, and just anytime you saw a piece of paper with green on it pass through, it said, "Must be Xbox." So next thing you know, that became the trademark color.
Yeah.
We did go back and validate that color and honed in as to which shade of green would it strike the emotional chord with the audience that we were talking to. And then there's the other two parts of it. The Xbox logo itself, the kind of emotional mark that's over the top of the word mark. That really started up from us having a lot of hallway conversation about what is gaming like? Well, gaming is like an escape. A portal opens, you put up your game machine, a portal opens, you travel into it, and no longer you actually kind of, in this sense, you're not actually watching a movie, you're not, things are not being delivered to you, but you're immersing yourself into the gameplay. So we start going that trail for a long time of discussion, and resulted in about 2 or 3 logos, and that was the one that both won in focus group tests internationally, and also best represented the energy that is within the box itself that is yet to be harvested, so to speak. And then the third part is the word mark itself that really stood for, we wanted to tell people that, hey, you know what, this is not a fly-by-night project by any means. It is a very grounded, very well-funded, very much bought in by the industry and partners and the game developers in the industry as the end-all thing. And if you look at historically, if you look at the Xbox logo itself, historically, if you look at architecture, they're very representational of structural either stability or process. Usually buildings are very symmetrical. And we had, the 2X on the side to really frame that. And really giving the little bow to the B and O, just give it a little muscle flex to kind of support the heavy lifting that Microsoft is going to do to deliver this product to the marketplace. So there's a little bit of science, a little bit of magic.
Same thing.
And yeah, and things just kind of come together.
It works really well, I think.
Yeah.
Are you a gamer yourself?
Yeah, I am. I'm a console gamer. I'm not a PC gamer. There's a difference between couch gaming and kind of more strategic postured PC gaming. I'm more of the, talking trash, sitting on the couch, having fun, having people come over, type of gaming instead of solo sitting down and one-on-one.
More interactive.
Yeah, I'm not that type of gamer. I'm a console gamer. Yeah.
So, about the Windows XP logo, what were some inspirations to redesign that, or what are some factors that you looked at with your committee to rebrand Windows for Windows XP?
The logo actually started from a higher executive, which defined the Windows platform as the software technology that brings machines to life so you can do amazing things. I and fellow members of the team translated that as it's a fabric of technology that allows anything to happen. And it started by saying, hey, you know what? Let's look at things that are more either magic carpet, or it's a flag that says we've achieved the not the ultimate, but at least a very high success point. So if you look at everything from man landing on the moon, putting a flag on top of the on the moon itself, to Aladdin's magic carpet. We try to tie a lot of those essence into the Windows brand, and we really wanted to communicate to the user that anything can happen kind of on this platform, and that designing a logo, one of the biggest things that we wanted to do was, traditionally, like the Windows logo had a little more baggage to it. It had both the logo itself, which had a lot of patterns to it, so it's not as easy to the eye, but it's a little more complex. To the platform itself, which was not as stable before, we certainly made vast improvement, streamlined the process a lot more, and to represent the team's kind of effort to kind of remove things that are not necessarily important, or to the kind of average individual's experience on Windows, and really honing in on what really defines human experiences on technology itself, and that logo kind of summarizes that for us.
So how was the XP determined? What was the reasoning behind that?
XP started, the word XP itself. The two-character XP actually, there was an effort in the beginning to define new Windows. Now we knew that, of course, it would be called Microsoft Windows. The question is, how do we actually signal to the user that this is something way different than before? We thought about a couple of different naming projects, and obviously the first one that came up was a natural migration from a 2000 to 2002 to signal the fact that this product represents year 2002 or 2001. Naming by year is a very chronological kind of next step, evolutionary step. We wanted something that really defined revolutionary.
Sure.
And we started going back to saying, what is Windows about? Well, Windows is about human experiences. It's about the fact that you don't get on a PC because you want to use the PC. You get on a PC to do something else. For example, you get on a PC to see a picture, a digital photography photograph that your mom sent to you, right? So you can actually catch up with the family. It's about those human experiences. That's what the brand of Windows represent, and the power for you to do that, instead of just going to it as a tool and just to experience Windows. Nobody goes and just experience Windows. People want to utilize Windows and sit on top of the Windows platform to experience something else, which goes back to kind of the human experiences. So we did that, and we started identifying what are the key words in that really just spells it for people. And we said experience, XP, and it just kind of took off from there, and it really stuck.
Yeah, it works. So what sort of projects are you working on now?
I'm involved in a different team now, looking at more leadership project and visionary project 4 years out. I can't really talk about too much, but it is I feel like I'm in the beginning of Xbox again.
Right.
There's something else coming around in the bend, and really trying to see what else we can do to really utilize all the resources we have at Microsoft and to its fullest potential.
Right.
And that's kind of something we're working on. Hush, hush, behind closed doors.
Right.
Can't really talk about too much.
It's an exciting time to start a new project, though.
Yeah, yeah, definitely. I think that both the PC industry and and generally the technology industry is looking for both Microsoft to take a leadership position and really just, I mean, this company is about inventing new things and new ways of experiencing life in a very technology-based way. And no other company will let you do that but Microsoft. So yeah, utilizing all the resources, looking at across company how to actually pull different people together and thinking thinking a little more ahead. Yeah.
So what sort of things do you like to do outside of work besides couch gaming?
Couch gaming? I used to have an expensive hobby of car racing.
Oh, really?
Until until it got too expensive. Now, lately, I've been actually my next thing is motorcycles. So I've got myself, not in trouble, but just an addiction to just riding a motorcycle in and into work and back from work and on the weekend and going out in the mountains and just enjoying the kind of the exhilaration and the freedom it gives you.
Sure.
So that's one thing I do. Another thing I do is I like to travel a lot. So my wife and I go different trips. For example, we just came back from Cozumel, Mexico, where it's a diving. It's a national park, underwater national park.
Oh, wow.
And so there we ran into, for example, 8-foot, 9-foot nurse sharks to big stingrays to big sea turtles to gulper fish that's about 250 pounds. And
wow.
I mean, it's beautiful down there. So to me, because what happens when I come to work is, as most people at Microsoft it's constant noise, constant interaction, constant kind of more constant energy going around the hallways, and that just gives me a complete break.
Sure.
Basically,
quiet and peaceful.
Yeah, definitely. That gives me a little bit of quiet time. Yeah, and I mean, you go there and it's just I go to the furthest place away from technology as possible.
Sure.
So, for example, I went to
sea.
and in Cozumel, rented a scooter, go to a hut, and you order a drink and a fajita, and if you ask them if your drink can be blended, they say no, we don't have electricity here. Sorry, it's on the rocks. And as a matter of fact, you better take advantage of the ice now because it's going to melt.
You can't even ask for ice.
Yeah, so it's that I enjoy that. That's a real contrast to what my everyday life is.
Right.
So those are kind of the things that consume my life outside work.
So where would you like to travel to next?
My dream was actually to go to the Red Sea to go dive next. Jack Cousteau named it as probably the top 3 location in the world. And unfortunately, with the politics going on, I can't really go there too soon. Maybe Bali. Maybe going to Bali. I've never been to Bali, so maybe going to Bali or going to somewhere in the Southeast Asia area.
Yeah, I've never been there either. I'd like to go someday.
Yeah, it's fun.
It's great.
Yeah, I heard it's a lot of fun.
Well, Horace, thanks for joining me today.
Thank you.
It's been great.
Thank you.
Well, that brings us to the end of another episode of the .NET Show.
Stay tuned for next month's episode where we talk about peer-to-peer applications built on the .NET framework.
And until then, we'll see you on the web.